You ever play a game and just stop? You're just looking around, completely floored by the sheer scale of the world. These sprawling cities, ancient ruins, massive landscapes. It just feels impossible. Well, today, we're going to pull back the curtain on the game industry's biggest secret for making the impossible possible. Let's dig in.
So it all comes down to this one question, right? How could a team of artists, no matter how amazing they are, build these absolutely colossal worlds without spending like a decade on a single project? Well, the answer isn't some kind of magic. It's a really brilliant, efficient system that completely changes how you think about building a world.
And that system, it's called a modular kit. The basic idea here is that you're not trying to make 1,000 unique objects. No way. Instead, you create a standardized set of pieces that you can reuse and reconfigure over and over and over again to build pretty much anything you can dream up.
Honestly, the absolute best way to get it is to just think of them as digital Legos. You've got your box of standard bricks, walls, floors, pillars, windows, and with that one limited set, you can build anything from a tiny room to an entire kingdom.
This Lego principle is the absolute foundation of modern 3D environment art. It's a total shift in thinking. You're not just making one-off unique assets anymore. You're creating this whole interconnected system of parts. So why is this so powerful? Why is this such a game changer?
Well, for artists, it really sparks creativity. It lets you reuse pieces in all these clever new ways. For designers, it means you can make changes super fast. If a level just isn't working, you can rearrange the Lego pieces instead of having to start from scratch. For the whole team, it means assets can be shared easily. And this is the big one for us players. It allows for these massive, optimized worlds that actually run smoothly.
Okay, but you can't just start throwing digital bricks together. It's not a total free-for-all. To make a kit that actually works, you need a blueprint. There are these fundamental rules and approaches that just make the whole system click into place.
First things first, you've got to know what you're building. Kits usually fall into one of two buckets. On the one hand, you have hard surface kits. Think architecture, sci-fi hallways, that kind of thing. These pieces need to snap together perfectly, right on a grid. But then you have organic kits, for things like rocks and cliffs. Here, the goal isn't that perfect snap. It's about creating pieces that you can kind of push together and blend seamlessly.
And scale. Scale is everything. As one artist put it, the larger the environment, honestly, the larger the kit piece is. I mean, think about it. If you're building a massive city, you're not going to make a kit out of individual bricks and tiny window panes. No, you're going to make entire floors, maybe even whole building facades as your Lego pieces. It's all about building at the right scale for the job.
So this all boils down to 4 foundational rules. Rule 1, stick to the grid. Every single piece has to follow a standard measurement, like meters, so they always snap together perfectly. 2, set your pivots correctly. The pivot is the point an object moves from. If you put it in a logical spot, like a corner, assembly becomes so much easier. 3, plan for scale. Just like a painter uses big, medium, and small shapes, your kit needs those huge foundational pieces, medium detail pieces, and tiny little accents. And 4, and trust me on this one, name everything logically. A file called wall4ma is 1,000,000 times more useful than finalwall03v2.
All right, so you've got the rules down. Now, the actual creation process isn't about brute force. It's about building smart. It's this iterative workflow that starts as a simple sketch and slowly evolves into a detailed world.
The core philosophy here is less is more. You'll always start with the absolute minimum number of pieces you need to get the look and feel right, because you can always add more variety later on. This is what keeps you from wasting weeks making, 500 unique rocks when it turns out you only needed 4 of them.
The workflow itself is just incredibly smart. First, you start with a simple blockout, which is basically a 3D sketch made of cubes and spheres. From that sketch, you start to identify the repeating patterns, the walls, the floors, the arches. Then you build the final polished kit parts based on those shapes. And here's the most important step. You immediately get those pieces into the game engine to test them. Do they snap right? Do they look good together? And only after you've built the basic scene do you go back and expand the kit, creating new variations only where you actually need them to break up that visible repetition.
But modularity isn't just about building faster. It's about building smarter for performance. And here's the biggest secret of all. The key to optimizing these huge worlds, it's not about the number of polygons. It's all about texture memory.
Think about it this way. In a traditional workflow, every single object gets its own set of unique textures. A sword, a shield, a chair, each one eats up a ton of that precious memory. But with a modular kit, hundreds of different pieces can all share the same small pool of textures. The memory savings are just
astronomical. And that is what allows these enormous, detailed worlds to even exist in the first place.
So how do they pull this off? Well, with a specialized texture toolkit. First up, you've got tileable textures. These are the workhorses, basic materials like brick or wood that can repeat forever without any visible seam. Next, you have trim sheets, which are pure genius. Imagine one single texture that's like a sticker sheet full of details, moldings, borders, little panels. You can apply bits and pieces of this one sheet to hundreds of different objects. And finally, for organic stuff like rocks, you use baked masks. This means every rock shares the same base stone texture, but a really cheap, simple mask tells the game engine where to paint on unique details like moss or dirt. You get incredible variety for almost zero performance cost.
So you've built your kit, you've assembled your scene. It's efficient, it's all on the grid, but it might look a little bit blocky. The final artistic step is all about hiding the seams and making the world feel organic and believable.
That's right. That final 10% of the work is all about hiding the fact that your beautiful ancient temple is, under the hood, made of repeating Lego pieces. This is where the artistry really comes back in a huge way. And artists have a whole bag of tricks for this. They can use something called vertex painting, which is like digitally painting with materials, blending dirt or moss across two different pieces. They use decals, which are basically super high-tech stickers, to add unique cracks and stains that break up repeating textures. They'll even create small skirt meshes to cover up that hard 90-degree angle where a wall meets a floor. And of course, nothing hides a seam better than a well-placed clump of grass, some hanging vines, or a little pile of rubble.
And all of this leads to the ultimate expression of the modular philosophy: kid bashing. This is where you take pieces from totally different kits, a sci-fi wall panel, a piece of industrial machinery, a bit of ancient architecture, and you just mash them together to create something completely new and unexpected. It's pure creativity, built on this foundation of smart, reusable parts.
So, the next time you're exploring a game world, look really closely at the walls, the rocks, the buildings. You'll start to see it. You'll see the patterns, the repetition, the clever reuse of parts. You'll see the digital Legos. It's not a shortcut, it's this incredibly powerful system that empowers artists to build the impossible. Which really just leaves one question: what worlds will you build?